Welcome, Hornets, and thank you for joining me today. Today we're going to be taking a look at operations when working with the polar form of complex numbers. More precisely, we're looking at products and quotients. So one of the things that we're going to be asked to do is try to multiply two complex numbers together in polar form. And this is actually quite straightforward. According to De Moivre, the individual who created and came up with this process quite a while ago, let's just take a polar form, the 2 cis 4 degrees, and we're going to multiply it by 3 cis 10 degrees. Now, according to De Moivre, what we want to do is we want to multiply the two numbers here. So we're going to find 2 times 3, and we're going to add, when we multiply, these two numbers here, 4 degrees plus 10 degrees. Now, if we were in radians, we just add the radians together. This should give us 6 cis 14 degrees. Notice how it's not difficult to work with and makes our life very, very easy. The hardest part is converting it into our cis form unless it's already given to us. And in most cases, it will be. All right, after all, if we have two numbers that are already in rectangular form, we might as well just multiply them using our rectangular method. Let's just remind ourselves what that might look like. If I had 2 plus 3i, and I were multiplying it by negative 1 plus 2i, I am going to just simply multiply my values together, just as we've done in the past. Now, that means that we would take our values and simply multiply them together. And let's just do our FOIL, first outer, inner, last. So we're going to have 2 times negative 1. We're looking at 3i times negative 1. Then we have plus 2 times 2i plus 3i times 2i. Now we do have to be careful because we get a negative 1 when we get an I squared. So we have negative 2, we have minus 3i, we have plus 4i, and we have a minus from our I squared and 6. We then add like terms and we get negative 8 plus I. And negative 8 plus I would be our answer to this product. Once again, why go and convert it into our cis form if we already have rectangular form and can simply FOIL? So keep in mind that this method is only when we are working with our polar form of our complex numbers. Now, if we're trying to divide is equally simple. When we are dividing, we simply subtract and divide. So let's go ahead and take 7 cis, and I'm going to put 2 pi over 3. And we're going to divide that by 2 cis, and I have pi over 6. So our idea is that we're going to divide the front numbers, the r's, our modulus, and we're going to subtract our arguments. So we will have 7 halves cis 2 pi over 3 minus pi over 6. This is going to give us 7 halves cis. Getting the common denominator is going to be 4 minus 1, makes 3/6, which is pi over 2. This is now our quotient of our two complex numbers written in polar form. Once again, according to De Moivre, when we have a product, we multiply our modulus and we add our arguments. And when we are dividing, we divide our modulus and we subtract our arguments. Couldn't be any easier. Alrighty, thank you very much. I hope this has been useful. If you found this to be useful, please remember to click like. And if you have any comments or concerns, please make sure you list them, and I will be more than happy to redo this video for you. Thank you very much. Please have a very good and safe evening. Cheers. Take care. Bye-bye.